Okay, let's wait for others to join. Okay, then we'll start a lecture. Yes, happy New Year. Welcome. The screen is visible, all of you? The screen is visible? Okay.
Yeah,
Okay. Okay, so let us start now. Many of the students had already joined. Okay, so very good morning all. Today the Vishal sir is in busy with some exam duty. So we are covering or we are continuing the lectures till what the Vishal sir had left. So I think the Dhruv has wrote that up to the BCD and the gray code. So these are the things I hope you already studied about the gray code, the BCD code, then the XS3 code. Okay. So I'm not going on much more details about this BCD and the gray code, but I hope that everyone knows that how we can able to convert any binary number system into a gray code. Yes or no? Everyone knows about how to convert a binary to gray code. Can anyone says what is the sequence of a gray code? How it is different? Let's suppose if I talk about the 2-bit binary numbers, it'll always be like a 0, 0, 0, 1, 1, 0, and 1, 1. But when it comes to the gray code, this one is the E, okay? So it comes to the gray code. What should be the sequence of a 2-bit? Anyone? What should be the sequence of a 2-bit? It's same as a binary? It's same as a binary or it's a different from binary? Yes. Avni, Asta, Bhavin, Breathe, Trasil, Dhruv, Divya. Anyone? It's the same as the binary pattern? Is it same as a binary pattern or it's different than the binary pattern? Anyone can put the audio on and can give the answer so that I can able to know that the students had knows or not. Okay, so in the gray code, the sequence are always like 0, 0, 0, 1. Then it will come as a 1, 1, and then it will be a 0, 0. Yes, correct. Divya and Breeze, what you said. Now, why these things are happens? Like why we sometimes while designing any electronics component, we always try to use this gray code sequence. The reason is, look at over here, from 00 to 01, only let's suppose this is the sequence being created in a transistor. So what happens when the sequence goes from 00 to 01, one transistor need to switch on and other transistors should be remain in the same state. But when from this, let's suppose from this one, from 0, 1 to 1, 0, the two transistors need to be toggle. Toggle means from 0 to 1, this transistor should be on, and from 1 to 0, this transistor should be off. That means, you know that whenever any electronics components getting switched on and off, it will dissipate the power. So let's suppose consider there are the millions of transistors. Nowadays we have in the chip, we have millions of transistors. So this, all the transistors are switched on and off at the same time, it can dissipate much more power. Okay, and that is what the reason. Sometimes we always try to prefer this gray logic. Look at over here. From 0 to 1, only one transistor has been toggled. From 0 to 1, the one transistor, it remains to the previous state. And from here, it will remain to the previous state, but this transistor has been toggled. So each and every sequence, only one transistor are getting toggled. This is an example of a 2-bit only. Okay, and that's why we always try to prefer this gray code. Now, everyone knows that how to convert a one number system into another number system. So this is what we had learned. Okay, now let's suppose if you want to convert a number system of a gray, let's suppose this is the binary number I have, 111101. If I want to convert this number system into a gray code, what I need to do, first number as it is, this first number write it down as it is. And now if I want to need in G2, do the XORing of this two number. What is the XOR of these two number? 1, 1, the number is a 0. Okay, do the XORing of the two number. Again, if you need G3, this one, then again, what you will do the XORing of that two number, will get a G3, same as this one. So this is how we can able to convert any binary number system into a gray number system. Now let's suppose if it is a gray number system, let's suppose if I'll convert gray to binary, it should get the same number only. Okay, so let us write first gray number 1, 0, 0, 1 and 1. I want to convert this gray number into binary. That means first number should as it is. Now don't do the operation of this two. Do the XORing operation of these two number. The answer what you got and the second number. What is the output you will get? Write it down here. There is a 1, 0, 1. Again do the XORing of these two number. You will get a 1, 0, 1. Do the XORing of this 1, 1, 0 and 1, 0, 1, 1. So you got a binary number only. So this is how we can able to convert a binary to gray and a gray to binary. Let's suppose, for example, if I'll ask you one question. Let's suppose 1, 0, 1, 0, 1. These numbers are in a gray number. What should be the answer in a binary? What should be the answer in a binary? Write it down, answer in a chat box. Okay, I didn't get the answer. So can you give the answer? What is actually required? What is the first thing? The same this bit as it is 1. Then the XOR of another number. This is the XORing of another number. That is a 1, 0, 1, 1, 1, 0, 0, 0, 0, 0, 1, 1. So this number we call as a binary number. Okay, so this is how we can able to convert these numbers, the binaries, into gray and gray to binary. Okay, so now let us go. Does anyone knows about this 8421 concept? Does anyone knows about what is the mean by 8421 code? Yes, anyone knows? Kautik, Pavin, Gaurav, Harshil, Vidhi, Runda, Yash. Does anyone knows about this 8421? They are the BCD codes. And this one, let us start from here. For example, I have this number 4, 9, 2 and 6. If I want to convert into an BCD 8421, it should be like this. Okay, the 4 should represent with a 0, 1, 0, 0, 9, 1, 0, 0, 1, 2, 0, 0, 1, 0, because whenever you write an BCD, each digit can be represented into a 4-bit binary value. Okay, so we can able to convert this 4 number into a 4-bit binary value. Any doubt in this? This is the BCD numbers. Any doubt? Okay. So now this numbers we call as 8421. See, listen over here. Look at the number 0. 8421, all are 000. If I want a 1 number and if I want to write in BCD, 1 means 0001. So 8421. Which number should I add? So I'll get as 1. So this is the 1. So I'll write 2 with 0, 0, 1, 0. If I need a 3, which two numbers should I add such that I will get a 3 number? The 2 plus 1. So always write 1 and 1 over here, 0 and 0 over here. What about 4? There is already 4 is there. So write down over here. Rest of them are 0. What about 5? Which two numbers? 4 plus 1, that will give you 5. So 4 plus 1, 5. And rest of them are 0. 6. That means 4 plus 2, 6. That is a 0, 1, 1, 0. Okay. The 7 means it's a 0, 1, 4 plus 2 plus 1 is 7. So this is how the numbers we came. Okay. And that is what we call 8421. Maximum you can go till what number using the 8421? Can anyone say? Using 8421, what is the maximum number you can go? Write down the answer in the chat box. Good breeze. Okay, so 8 plus 4 plus 2 plus 1 will get a 15. Till 15 you can go. Okay, 0 to 15. So that is 8421. Same way we have 2421. Same way. If I have the 3, you can add a 2 plus 1. Okay, so that is a 3. What is the maximum number you can go? 2 plus 4 plus 2 plus 1. That is a 2421 number. Okay. We never use that number system, the 2421, anytime. Now coming to the access 3 code. Access 3 code is a addition of a BCD code plus 3 will give you the access 3 code. Now here, let's suppose I have a 000 in the binary. But if I want to represent in access 3, I need to add plus 3 number to convert into an access 3 code. Okay. So here, any number, any binary number, if you add 3, that numbers will convert into an access 3 code. So look at over here 4, it represents with a 0100. Add 3 number to it, it will give you 7. That is a 4 plus 3, 7. For example, take this as a sample problem. So I have 3, 5, 9. When I do the access 3, 3 plus 3 is 6. 5 plus 3 is 8. 9 plus 3. 9 after that A, B and C. So this is C. Okay. So this is how we got the number. Is it clear? The access 3 code also? Is it clear? The access 3 code also? Okay. Now coming to the point we call an ASCII. Now the ASCII stands for, it's like an American Standard Code for Information Interchange. That means the alphabetical letter what we are using and somewhat the symbolic representation to transfer the information or the exchange of information. Now in the exchange of information, I can say that if I'll ask you one thing, your keyboard, it always looks like a horizontal. Does anyone knows what is the reason behind that? See, whenever you press any key, let's suppose if you press G as a alphabetical number, and that number should go and display on the monitor. But inside your laptop, there is a one electronics component we call as a microprocessor, doesn't understand what you mean by G. So once you read a G as alphabet, you need to convert first that alphabet into a binary number system. Then the processor will understand that this is a binary number system, and then you can able to this binary number system again converts hexadecimal and ASCII, and it will display on the monitor. Just a minute. Okay, so that is the reason we have a laptop keep it in like a horizontal way. You'll understand why we have that, because let's suppose consider in this form, you look at the keyboard, like we have the 15, that is a 0 to F, different rows we have, and 0 to 7 the columns we have. Okay, but nowadays the systems are getting upgraded, so they might be find some different way, but the previous system what we have, they are coming in this way only. Okay, this is what the ASCII code chart what we have. Now look at this thing. Let's suppose consider you have pressed the key K. Is a K, this K. How many bits are there to represent 0 to F, and how many bits you require to represent 0 to 7? Can anyone? How many bits required to represent 0 to F, and how many bits required to represent 0 to 7? Write down the answer. How many bits required to represent 0 to 7, and how many bits represent 0 to F? How many binary bits are required to represent 0 to F? That is the maximum number F. And how many bits you require to represent F7, sorry, 7 number? Write it down in the chat box. The binary bit for F and binary bit for 7. Write down the answer in a chat box, or if you want you can unmute yourself and give the answers also. Binary bits is very easy question. Okay, 7 3 bits and F 4 bits. Good, Divya. So here, whenever you press any key of an alphabetical order, so what happens there? It will go to the K, which number, which row, and which column. So 4. So you'll write from here, this one is a 4 number that is in the binary. You could go to the vertical, which is the number line, row, that is a B. So from there you'll get a B number. So when you combine, it's a number 1001001. This is the binary number, and that represents the K number has been placed. So in a desktop, it is the algorithm has been write like this. Can if case this number comes, go and display this character. It is clear, all of you? This is why the keyboard is always be like in the horizontal way we have. Now, for this alphabetical number, you tell me what should be the binary bit. It's a capital S, it's not a small s. Write down the answer again in the chat box for this capital S. Good, Breeze. It's you say it is a 1010011. Okay, let me check. So S5. So you write as a 101. Good. So if it is this one is 0011, that is what you wrote. Good. So this is how we can convert any ASCII numbers from a ASCII code chart into a binary number. Now coming to the converting the number system, those is all the things you already studied in the digital electronics, but these are the the CO consists of a first chapter, so you have to study this because might be the GTU takes the offline exams also, and they might be asked the questions from a digital fundamentals also. So what we can do over here, if you want to convert any number systems into a decimal, any means which are the number systems we have except the decimal, we have the octal, we have the binary, and one more thing we have, what is called hexadecimal. Okay, so these are the three number systems you can able to convert into decimal, and this is nothing but a representation of a base number. So let's suppose if I have this number, I'm just checking your knowledge that you have learn to convert these numbers into a decimal. What is the procedure you will do? Let's suppose if I have this number, I'm not taking the simple example, the floating point number, that is a 1010.01. How will you convert this number into a decimal? How this number you can convert into a decimal? You can unmute yourself and give the answer. I don't have any problem, please. How we can able to convert this binary number system into a decimal number system? Anyone? Okay, might be no one. Good. So 10.5 is good. At least you try. So what we'll do, first we'll write as 1010. Then it's okay. Directly you can do like this also. Like here 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. This one is a 2 raised to minus 1 and this one is a 2 raised to minus 3. Now when you add this all together, it will give you the 10, what 10.25. Okay, good breeze. Okay, now if I have this number, it's already been converted. So what I mean to say over here, if it is octal instead of binary, that means you need to take 8 raised to. Okay, if it is binary, it's a 2 raised to. If it is octal, then it's 8 raised to. What happens if it is like 1, 5, 16 or 1F 16 and then into decimal? That means you need to multiply with a number the 16 raised to. Okay, so don't forget this. You can convert any number system into a decimal number system. Let's suppose I have this number. Okay, I already have the example. So what should I do? This one is 8 multiply 16 raised to 0. The C multiply 16 raised to 1. 4 multiply 16 raised to 2. And this one, the 2 multiply 16 raised to minus 1. When you add them all together, you will get a number in a decimal number system. Okay, so we have this. C means you know. Okay, so I'm not discussing that thing. So that is a 12. So 1224.125. That is the answer we are getting. So this is how we can able to convert any number system into a decimal number system. Let's suppose if I want to convert the decimal to binary conversion, we always divide the number. Let's suppose here we have 6. So 6, the number, we divide it by 2. 2, 3 are 6. So no reminder. The 2 ones are 2. 1 is a reminder. 1 should not be over here. So 2 zeros are 0, which is the remainder. Again 1. Write down the answer from last work in terms of MSB to LSB. So 1, 1, 0. This number will be in the binary. I hope you know this all the things. So if you know these things, solve for this and write down the answer in a chat box. Good. Yes, Suchi. These through. Very good. Okay. So let us check the answer what you wrote. So this is how we can write the data, and from here you can take the 0 as a out. Again the 1 take as out. Sorry, this one is the first 0. Okay, 1 as out, and then here from 1, then 0, then 1. Go with the 4 decimal, that will be the enough. Okay, so very good. The answer is 1101. So how many students have wrote the same answer? So most of the students. Good, very good. So now let's suppose if I have this number, so we no need to solve, but what is the concept over here? Here is a decimal and here the number is octal. So what is the things you need to do? Instead of dividing 2, you need to divide it with 8. Okay. So here that gives you the data. Okay. Like the converting from MSB to LSB, and here and this one from this one. Okay, MSB to LSB set with a like 32702 point, this one, the 151. So that will be the answer. Okay, so I'm not explaining that thing, but you knows it very well, so I'm not explaining that. If it is a 16, then divide it with the 16. Okay, that will be good for you. Okay, so very good. Now let us have the next we call as a complement arithmetic. So I hope everyone knows about how to convert any number system into a the complement method. Okay, it's like one's complement and the two's complement. We can able to do it. So if I have any number system, let's suppose this number, you can directly complement from 1 to 0 and 0 to 1, again 1 to 0, 0 to 1. So invert the numbers, it will convert into a one's complement. When you need to convert into a two's complement, you can directly add 1 to that number. It will convert into a two's complement number. Clear all of you? So this is how we can able to complement. Let's suppose here, if you don't know this, then you also can able to convert into one's complement by subtracting the number 1 1. So 1 0 1 0 1. Subtract the number. So the 1 minus 1 is a 0. 1 minus 0 is a 1. 1 minus 1 is a 0. 1 minus 0 is a 1 and the 0. You will get a complement number only. Okay. Let's suppose if I have 9th complement, then what you will do? From where you can able to subtract, write down the answer for this two questions, 9th and 10th complement in a chat box. What is the answer for that? Write it down in the chat box. I need a 9th complement and a 10th complement. I don't want the ones and twos. What should be the 9s and 10s complement? For the 9s complement, when we subtract from 9, okay, 99 minus 28 will get 71. And if I need to convert it into a 10s complement, 71 plus 1 is 72. So this will be a 10s complement method. Let's suppose now if it is coming to the 15th and 16th complement is also there. The 15th and 16th complements are also there. So what we can able to do, let's suppose for example, if I'll give the number, the same number, let's suppose 28 is there, and if I want to convert instead of this, let's suppose 2a is it 10. Find out the 15th and the 16th complement. So from it will subtract it. What should be the answer? From where you need to subtract the data? That is what my question is. What should be the answer in the 15th and 16th complement? Okay, 15th D5, very good. Devers. Okay, so subtract from FF to 2A. Okay, are you getting or not, Devers? Directly subtract FF from 2A. So F minus A, it's like a B, C, D, E, F. So 5. And F minus 2, so it's a D5. Plus 1, that will give you the D6, and that is a 16th complement. Good, Devas. Now coming to the point over here, like if I have a signed number, that was minus 22, minus 13, so how you represent that thing in for a computer? Because the computer never understands what you mean by minus 50. So that number we call as a kind of a fixed point representation. Here, this bit are always be represents for a signed number. That means, SIGN, sign magnitude. Now this bit tells to the computer whether the number what the computer had got is a positive or a negative number. If this number is 1, that means after converting this all the binary numbers, the numbers what is obtained in a decimal, that will be negative. And if it is 0, that number will be positive. Okay. Clear all of you? Is it clear? Clear all of you? So now let us start with this. I told you this one represents the sign magnitude. So how many bits are total representing? 7 bits. So 2 raised to 7, that will 0 to 7. The 7 bits are there. Total 8 bits, but 8th bit, that is the 7th bit, has been represented for a sign magnitude. So 0, 1, 2, 3, 4, 5, and 6. 6 we have. So range of a positive and the negative numbers goes from 127 to minus 127. So if you have any numbers in between this range, can represent with the sign magnitude. Okay. Now let us start with the sign representation of first with the plus 12. If you have the plus 12, first what you need to do, first convert that number into a binary, that is a 0, 0, 0, 0, 1, 1, 0, 0. This indicates the number is a positive number, and rest of the bits should be written like this. Okay, don't write, because 12 comes in between the range of 127 to minus 127. So you can represent in a 6 bits, 7 bits, sorry, 0 to 7. Now, if it is 1's complement, if you want to find for a positive number, it's same. There is no change in the 1's complement. This one is for sign representation, and rest of the bits remain same. Remember, for a plus 12 I am talking about. And I'm not talking about the 1's complement, it's a 1's signed magnitude complement. And written over here, see this one. Sign 1's complement representation and sign 2's complement representation. If the number is a positive, and if I'll ask you to represent the signed positive number, you should write the same. For the 2's complement, also the same number. I'm talking about positive number. You will start with the negative number. First, always write, forget about the negative sign, always write the binary number. And then 1 represent what? That the number is a negative number. The number is a negative number. And the rest of the numbers as it is. Here it will be changed. 1's complement means for a negative, this remain as it is. The rest of the bits are inverted. Rest of the bits are inverted. In the 2's complement, do the addition 1, you will get this number. But this will not be changed because the number is still negative. Is the thing is clear, all of you? Is it clear? Is it clear? Is it clear, all of you? Okay, so no doubt. So if I'll ask you to represent a signed 2's complement of number plus 15, not a plus 15, 15, okay, plus 15, let me give this another number of plus 22 and minus 22. Write down the answer in a chat box. 22 and the minus 22. Write it down in the chat box. What if it is 1, 1, 1, 1, 1? That will go out of the range, beta. Dhruv.
Yes, sir.
That will go out of the range. I had given you the range, I think so.
Yes, yes.
Okay, that is one. Okay, that's why in the first itself I told you, if you are defining the sign numbers, the range should be 127 to minus 127. So I had given the number, represent that numbers into a binary and write down the answer in a chat box. Write down the answer in chat box for plus 22. Okay, good. Suchi, the 0, 1, 1, 0, 1, 0. First one is for first one. What is it, Devas? You wrote this number. It's for sign binary. First of all, it's a binary, correct? Of the 22. Is it correct, Devas? Okay, so first is a binary, and then you wrote the ones and the twos complement. Okay, this is good. 2 is to 0, 1, 2, 4 plus 5, 6. Okay, good done. Okay, plus 22. Then convert the numbers into sign. But how this floating point representation takes place? Now, what do you mean by the floating point? Let's suppose this is okay, plus 22, plus 12, plus 25. But all the numbers are okay. But let's suppose if I'll ask you to represent 11.25 is little bit tough and difficult to find or to convert that number for the computer to understand. Okay, 11.25. It's okay, but you are representing the 11.25 also. But to represent this number, let's suppose this one. To represent the floating point number, this one, 11.8. Okay, in terms of 7 bits is somewhat difficult. You cannot write like that. 01.1001. No, you cannot write like that in a computer. So computer won't understand about this decimal point. How? What should I do for that? Okay, so that is not possible. So what we are doing, we are trying to convert this also into 8-bit, the floating point numbers. We'll understand the things. So the first thing always represent, that is a sign magnitude. The first MSB bit are always represent with a sign magnitude, and the rest of the one, it's a sign magnitude of an exponent. Now, what do you mean by the exponent? You know, the 2 raised to 3. It is a sign of an exponent. If it is 2 raised to minus 3, it's a negative number. And you know, if it is positive, that bit should be 0. If it is negative, the bit should be 1. That is the sign magnitude of an exponent. Okay. Now, here, these are the exponent. Let's suppose if I have 2 raised to 3 and that is positive, this number should convert into a binary and it should be right over here. That is the exponent we call. This is the exponent. Okay. And it should be in the bit of 2 raised to 3 only, 3 bit, the range of 3 bits only. And remaining are we call as a Mentasha. Now let us take an example to understand the thing. Let's suppose take a first example, 11.8. You know how to convert into a binary, so you had converted this number. Don't go till the more decimal numbers. Try this point to be put it over here. If I have 1,000, I would need this point to be over here. What I'll do? I'll divide it with a, what I'll do? I'll divide it with 1,000 only. Yes or no? Okay, I'll divide it 1000, so this point will, yes, this point will come over here. Okay, or what you can write, it's a 1.000 into 2 raised to 3. Like this also I can able to write. Yes or no? Is it correct? Okay, so this point will come over here. Now, sorry, not a 2 raised to 3, it's a 10. I am talking about the decimal point. But if we are talking about a binary, that is a 2, that means instead of 10, you need to use 2 over here. Okay. Now, I need to change it over here, this point. So, multiply with a, this is a 2 raised to 3. Okay. So, first try to make it like this, and here only the after a point there should be 3 numbers, rest of the numbers should be removed, because 3 bits are being used for a exponent. So 3 bit means maximum I can go up to 1111. Okay, 111, sorry. Okay, so now what I am doing, I am writing like this the value. So I have this, from this I had got this, and 2 raised to this 3 is converted into a binary. Now let us try to fit the bit. So what is the first? The magnitude. The number is positive, so write down 0. The magnitude of the exponent is also positive, so write down 0. This 3 is for exponent. What is the value of an exponent? It is 0, 1, 1. What about the Mentasha? Look at this. After a point, what is the number I have? We call it the Mentasha. This is 0, 1, 1, 1. So this number represents in terms of 11.8. Any doubt? The students have a doubt? The student, any doubt?
Clear, sir.
Okay. So what you can able to do, you can write down the attendance, and those who write, they can leave. But remember, it should be in the sequence. Okay, don't write it randomly. Write down the attendance and then you can leave. Write down the attendance and you can leave. Don't want the attendance? In a sequence. Okay, you can leave. Those who wrote, they can leave. Those who wrote, they can leave.